Now we get the fun part. You have to get the pistons on. If you ever need to buy clips, they're CW20s. That means they're the small ones. These are smaller diameter, like 50 thou or so. So they're a lot easier to put into the wrist pin. Those ones that are like 65 thou thick or whatever they are, they're twice as hard to put them in. I don't like them. Okay, this is your piston. MS plug. What's an MS plug mean? It means put the darn plug in the crank over here.
Oh.
Did we forget to do that? Good to get written down. Okay, that appears to be the rear. And we put that on the far side, didn't we? I think that's what we did. I don't remember. Okay, I'm going to put the clip on this side because we're going to go from the left side for access. So it's a little easier. Now to be safe, you want to cover this area up right now, so when I'm putting this in, it doesn't go pong and go into the hole. So we're going to use this right here. Like that. So now I can just drop down that hole. Go like that. How's that? Are you happy? I just bounce around and goes in this other hole on this side. Okay, there's our mark. So these are thin enough, you just kind of push them in. Like that. So they're almost in. You get the two tails inside the groove. And now we're pulling this up like that. You can also use the wrist pin to do it. If you have a nice, good, solid hit, you know what's in there when you hear that. But I always like to double check. So I take my screwdriver and I try to rotate it. If it doesn't rotate, it's probably pretty good. See how the clip is over the hole there a little bit? So when you come in to pull it out, you get behind it, pop it.
Oh, okay.
And the tang end's right on the other side of the hole.
You don't want to put the slot right over the hole.
Yeah, otherwise you got to rotate the clip around to get over there. So, the biggest thing is you want to hear that noise. Yeah. Yeah, this side didn't want to run. It's a little tight there.
Was it the other wrist pin?
Must be something, because this one was going there pretty nice. No, something changed. That's weird. What did we do different? There it goes in. There's a burr.
They never had to be pushed in before.
There's obviously a burr up here on the edge on this side. No, they always slip real nice and easy. You're a little too close to that camera. That's weird. Once it's in there, it's loose, like it's supposed to be, but I don't know what happened there. That is weird. As long as it doesn't come up that high, you're fine. That is stupid. What happened? Because it worked the first time. How many times I this motor together? No problem. Our typical assembly issues we have all the time. Something always happens. So that's the two tangs are in there where they belong. You can take your wrist pin that won't go in the hole. See, it fits in there pretty good right now. See, I popped it in. Just from force. What if I warped the piston by prying on it? That one works correctly. I don't know what happened to this because it was working fine until it wasn't. That's weird. I have no idea what's causing that. See, it's not a burr. And once it's in there, it's not like it's warped. It's up here on this edge right here. See, once you're out of that, it's free.
Just needed a hammer.
Well, what happens, I got some kind of a burr right on this side, right on the edge. So when I was pushing it over here and pushing down on the clip, it had to burr the edge slightly, I guess. Now it works fine. So I know it had to be out here on this edge, so once it goes across that edge, it's loose. So I just put it out here and I just whap it straight down, because I know it's on this edge, it ain't over in this corner. And popped it down and we got clearance. Just literally, that was only like a half a thou of something sticking up. I still don't know what it was. You still can't see it, obviously, but it's a, it's a chamfered edge. But obviously something affected it. That's weird. Never had that happen before. It's just par course for this vehicle. Okay, so now we have these in there. Now you gotta put your rings in. So this has a wire in here. There it is.
Oh, the wire's there all the way around?
It's from here to here.
Oh.
What's nice about the wire is it keeps the rings from overlapping the gap. So you can't overlap it. That's the biggest problem I have with working on twin cams. Is the rings are so damn thin, they like to hop over and overlap. This prevents it from overlapping. There's no way it would overlap because it has a guide in there. It can't overlap, which is really nice. So whoever makes these rings for Wiseco, these are definitely higher quality than the normal rings. Okay, so I got the gap right over in this area here. Then we take this ring over here. You go from here to here, so now you're overlapping your gap, the first thing you do. Because that's how you make sure you don't overlap the rail normally. But see, on this piston it doesn't really matter. Now this is the only ring that you can wrap it around like this, but you still want to pull up on it as you go across. I even put my thumbnail underneath it, pull it across, drop it in. You don't want to be scoring across your surface. Same problem we had the wrist pin can happen with the ring gland. Okay, so we have our spring gap is here, oil ring gap is there. You go 180 over and you do the next one. Bring it around, pull up on it, drop it in the hole. It should be nice and free. There's a little bit of a drag, but not much, just nice and free. Okay, your second ring, any marking goes up. Dot always overrules everything else, but any marking will go up. See markings anywhere? Is that an N right there maybe?
Looks like something.
There's an N. If you look through that, you might be able to tell. There's no markings there. So there's an N right there. Probably that's the manufacturer's name. Okay, now these, if you wrap this ring, it becomes a spring. It will never seal. So when you put the ring on, you got to spread it with your thumb and push with your fingers over the groove. So you put the ring gap where you want it to be. See how it's in the groove? Spread it with your thumbs and just push it over the piston with your finger. See how it's in there? When you get to this point here, you can slowly push it over the edge evenly. Don't force it. Then once it goes over, it just slides down. See? And it rolls. It should be nice and free. It shouldn't be sticking anywhere. If it sticks, you bent the ring.
So if you twisted it, it would stay twisted.
It'd be like a coil spring. It'll never work. The way rings work is the cylinder pressure comes down around the outside of the piston, pushes against the ring, and then whatever tension is built in, which is your thickness of radial depth this way, and the thickness this way determines how much spring tension is on this ring. This has a certain amount of spring tension. Then the cylinder pressure goes around the back side of the ring and blows it out. So the more cylinder pressure you got, the more the ring will seal. Now when they put a pressure back ring in here, they'll have a gap in here, or they'll put little grooves up in here where they'll go through. It used to be in the old days you had pistons, you had holes in the top for racing motors. So what they do is they'll put a chamfer cut on the ring back here, but usually on a street motor they don't do that, they just rely on the tension of the ring to do the work. On a racing hot rod ring, it'll have a chamfer on the back, which will, the air go back behind it, and hits on the back of the groove in the back there, and blows the ring out. So that's how they work. So see the numbers right there?
Yeah.
It's in something, in, was it 2 something, 5 maybe? I can't tell.
Yeah, 25.
I'm looking at it upside down, so. See this side here, there's nothing, so that goes up. Same thing, put the ring in the groove, spread it with your thumb, push with your fingers, see I just went right over, boom, done. Nice and free, see? See if the rings are bent, they won't seal, because when they're sealing, it'll stick up, and it'll have a gap that go around and right underneath it and bypass. Because the ring seals against the bottom of the ring pushing against the top of the ringline groove. That's what seals it. Or the bottom of this groove right here.
Mm-hmm.
So the ring pushes down against the groove. It doesn't go on the top side. The piston does not come down against this. The pressure from the ring pushes against the piston. And that's how it seals. It doesn't seal on the top, it seals on the bottom of the groove. So when you got when the ring is twisted or warped or bent or anything, it doesn't come down and seal unless it has a really lot of pressure. But you can't get the pressure because it blows by. It bypass. So it doesn't work. So now when you got these all on there, we got a ring gap right here on the ring, on the O-ring. So we turn it 90 degrees, which is where the other gap was. That's where you put the one ring. And the other ring goes 180 over from there, goes over there. So I don't like the ring gaps on the thrust face, front to back, or on the side face. I went on the 45s. So now every 45 degree on these corners here, there's always a ring gap. Now once you start the bike moving up and down, your different crosshatch pattern induces a ring spin, and these will start to spin at different RPMs. And the different crosshatch angle determines how much spin you get. If too much RPM wears things out, too little won't seal. So it's all part of how you do your honing. So there's our gap. Goes over there. So here goes here. Well, see, the bottom oil ring doesn't do a damn thing, but see how it leaks out of here? And usually there's holes in through here.
Mm-hmm.
Let's see oil out. So the bottom oil ring is not the one that does the work. So if you have a crappy ring that's all screwed up, put it on the bottom because it doesn't really matter. All it does is support the spring. The top oil ring is the one that does the scraping on the cylinder and actually does the work. It helps to know how things work so you know when you got problems what you can do. So gap, gap, go way over here. Now these are a steel ring, not a cast iron, that's why they're more flexible. Plus you got that spring tension helping straighten the ring out. It's the same deal though, if you bend that top ring there, it'll still have issues sealing. Should be something right there. Yep, there's an N right there. I can see it. Turn the gap. Boom. See how this kit has a gap in here? It's actually a V groove. That makes the distance between these two rings bigger, more volume. So it's like having a bigger air tank. You got a certain amount of air volume going past, it pressurizes your air tank. If it's a small tank, it pressurizes quicker than a big tank. So you don't want to unload this ring here, because then it doesn't work. When you build up pressure in here, it lifts this ring up, which makes it not seal. So it causes a problem. Next to the second ring is a scraper. It scrapes whatever this oil ring doesn't do, it gets. It scrapes off more of it. It's not really made to seal compression. It's not made that way. It's got a twist to it, it's made differently. So having a nice big groove in here, or more distance between the ring lands, will make it not have that cylinder pressure. So if you got leakage coming past, you let it bleed off. That's the reason why I put a bigger gap in the ring also. It lets the pressure bleed out quicker. If you run like a nitrous motor or a turbo motor or a blown motor, you want to have a real deep groove in there, as much gap you can put in between it. But you also want to have a real thick head of here, because the heat and pressure up here will destroy the top ring too if it's too high. So it's a trade-off between the gap between the two. That's why a lot of them they put the oil ring goes way down here to allow you to move all these down. So there's lots of tricks. And almost none of that matters on a street bike because you're not working it that hard. There's a number over there. But when you're racing, it does. Problem is, most street bikes on motorcycles like having a race car motor, the way they're built. Something like that. Now, if we still had burrs on rings, it would lock up when it came down. You can also see how the ring is lined up. If it was bent, it'd be like this. You would see it. So where's our gaps at? Okay, one gap right there, and the other gap over there. Full stack moves. Good. Alright, those are ready to go in the cylinder. Alright, be back in a minute, get some gaskets.